Okay, ladies and gentlemen of Precalculus, we're going to pick up where we left off yesterday. And I think at the end of the day yesterday, didn't we finish problem 1? Is that where we were? We finished this one yesterday, right?
Yeah.
Okay.
Do we have that paper?
Handed out yesterday, yeah.
Did you take it back up?
No. That was the last one we started. And what we're going to do today is go as far as we can in this. Then by the end of class, I'm going to have to hand out the review packet, because we just have to, and then you'll have that review packet to work with over the weekend. And then also then Monday and Tuesday, I'll be able to help you review everything that's on that packet and other questions you might have. But we did this one yesterday, right?
Oh, this one.
You have that yesterday? Okay, in 5th period class, or 6th period class yesterday, and I'm going to probably work most of these problems myself today, just to give more time on this, going through here. And so here's the setup for problem 2, where we have our common difference. So D is going to be equal to 3, and then our a sub 1 is equal to 2, and we know that we have, if this is term 0 here, we know that by counting, and basically what you do, if you take 29 minus 2 and divide that by your common difference, you get 27 divided by 3, which is 9. And so that's why you have term 0 through 9. So you have to be careful here, because you're going to have 10 total terms. So this is what happens of this series here. This is called the 10th partial sum. Which means the adding up of the first 10 terms of this series, or of the sequence. Okay, does that halfway make sense? Okay, so let's go on. We're going to do as many of these, like I told you, as we can. Okay, yeah, I want to skip 3, skip 4. Okay, let's look at 5. It says, write each sum using summation notation, assuming the suggested pattern continues. What is the pattern you notice here? They don't say anything about if this is arithmetic or geometric.
-2.
What -2? Nicole says negative. Yeah, so what it is, here, Nicole noticed that our common ratio is going to be -2, right? Okay. And then it says summation notation. Well, summation notation, remember we had this function like a sub n is going to be equal to our starting value times -2 to the power of n minus 1. You remember that from the formula chart, right? And what it is, we're going to refer back to this formula chart a lot today, and we're going to actually do all these formulas here today. Well, this is the average. This one here is combining the arithmetic sequence and the series by dividing by 2, because this takes a1 plus a sub n times n divided by 2. So that's like a combination equation. We're going to be looking at all these different equations today and how to put them on there. And if you don't totally have everything down lock solid by the end of today, there are going to be examples like this on the review packet too. So if you feel like, hey, I don't understand everything cold today, there's going to be an opportunity. So I don't want you to get all freaked out about it. Okay, so now we have this, but for our summation notation, it's written like this, and we're going to start out, and it doesn't give anything here, but if we say with if we start with n or k is equal to, we want to start out with the first term, so k equals 1, and we have the pattern continues. When the pattern continues, what we do is we write infinity on the top. So what's going to go in here? What's going to go here? 6 times negative 2 to the power of k. And I don't know if it's k minus 1. Let's think about this. Because if we put in k, if we make this be 1, well then our first term would be negative 12. So we have to put k minus 1 to make this work. Or if we started with k equals 0, we would make this thing just k up here to infinity. So this is equivalent to k equals 0 to infinity, and we have 6 times negative 2 to the power of not k minus 1, but just of k. But either way, when you plug in the 1 here, this is going to be negative 2 to the 0 power, and this is also going to be negative 2 to the 0 power. You see the difference between the two? This here, your exponent is k minus 1, and here, starting at 0, your exponent is just k. So this is it in summation notation. Now, could you put this in the calculator? Why can you not put this in the calculator? Yeah, because infinity will work. What happens is you're going to burn out your calculator. What I want you to do is get your calculator out. Okay? It's not going to be on a watch. It's not going to be on a phone. It's going to be on a calculator because we're going to do some things. And by the way, this is also a divergence series, is what we call this. And I'm going to talk about what that is here in a minute. Okay, next. This one here, how would you do this one, number 6?
Did we finish number 5?
Yeah, that was number 5. 5 was finished in the summation notation. Yeah, so this one here, r is equal to negative 3. All right, very good. And what's a sub 1? 5. So how would we write this in the pattern continue? We're going to go to infinity. Do you want to start with k equals 1 or k equals 0? Which one do you want to do?
1.
1. Let's try k equals 1. Then we're going to have over here what? So we'll have 5 times negative 3 to the power of k minus 1. And that, my young friends of precalculus, that's our answer. Okay, questions on that one? Okay, good.
How do you figure out what k equals on the bottom?
Okay, what you have to do is, I kind of showed you that earlier. What happens is you have to look at what happens if I plug in 1. If I have k equal 1, it has to come out to the first term. So you just do a test. So if I have k equals 1 and plug this in, well, I'm going to get k to the 1 minus 1, or negative 3 to the 0 power. Well, that's 1. So if I plug in 1, the first term is going to be this.
Okay.
And then you try the next number. If 2 is going to work, then you should get negative 15. And so if you try 2, you get negative 3 to the power of 1, and negative 3 times 5 is negative 15. So just make a couple of tries to see if that works. And if you're sure after a couple tries that that looks good, well then you know you started out right. So that was a real good question there. That was like a worthy question. Okay, thanks for being worthy in the classroom today. Okay, next. find the sum of the arithmetic sequence, and we could add this up. What I want you to do is try to write this one in a summation notation and see if you can punch this in the calculator to get this. Can you do that? And I'll show you that in a minute. Papers. Get our other paper ready to start on. Does anybody need to borrow a calculator? You got a calculator there? I like the retro 83 plus calculator. Next one here. Okay, I'm going to show you what I have on this one here. I'm counting here, and I count 6 terms. So I'm going to call this one the 0 term, and 1, 2, that'll be first, second, third, fourth, fifth. So what I'm going to do is set this up here from k equals 0 to 5. Now I'm going to put a sub 1 here, a sub 0, which is -7, plus, what's our common difference here?
4.
So 4k. Did you get that for your?
No, I got -7 plus 4 to the power, the square root of k minus 1. Not square root, just square.
Yeah, the thing about it is you have to look at it and say, well, this is an arithmetic sequence. So you're not talking about an exponent in this case. Okay? Does that make sense? So what this is this exercise set is having you have to sort of figure it out. Did anybody put this in the calculator, figure out what it was?
18.
18?
No.
Or without a calculator? So you got -10, that's going to be -9, and that was -4, plus 9 is 5. Yeah, it's going to be 18, yeah. Yes? Yeah. So it'll be 18, all right?
You need your math.
Let's go to next one. Okay, this one here, I want you to try to set this one up. Number 8. And what kind of sum do we call this one? A what? What kind of sum do we call this? Okay, we call this a partial sum. How do you know it's a partial sum? You call it a partial sum, and the reason you know it's a partial sum is because of this thing I shall show you. Okay, if you have this up here, that means it's an infinite sum. If you have a number up here, what does that mean? Partial sum. So what do you get for your number up here?
57.
Okay,
Oh.
5,
I thought you were
and k is equal to 0, and then what goes here?
-8 plus 7k.
Negative 8 plus 7k, and then Nicole, you figured it out?
57.
57. Did anybody add all these up to by hand before using the sum? You did too?
9, 3, 16, 26, 57.
Yeah, so just, I want you to do that just to get some confidence that you know what's going on here, right? How are you, Elizabeth, are you doing okay on this? Anybody having some question? Justin, you okay? Riley, you okay on this? Okay, good. Benefits of small classroom. Okay, this one here, you're not given all the numbers. I want you to see if you can set up a summation for this one here, for number 9. Anybody finished with it yet? Maybe. And this one here, what I would do, since that actually is 1, I would go from terms up 1 to 80. Is the way I would handle it. And just go from k equals 1 and just put k here and put 80 up here. Does that make sense? Yeah. That way you're going to have 1. The first term is going to be 1, second term 2, and so on, all the way up to 80. And so what do you get for your answer on this one? Yeah.
I got 160.
160? Okay, what you should do, it should be equals to n times a sub 1 plus a sub n over 2. So you should get 80 times 80 over 2 times 1 plus 81.
When do we know what fraction or what equation to use?
Okay, I'll show you why the equation, how you know which one to use. It's this one right here, sum of a finite arithmetic series. You know it's arithmetic series. How do you know it's arithmetic series? Well, the reason you know it's arithmetic series.
Mr. Jerome, can I have one of your, is Miss Sam's here?
She's in the bathroom.
She went to the office.
She went to the office? Okay. Thank you.
I don't know what they're doing.
Drug test.
Oh, okay. All right. So actually, that's going to be, that's going to be 1 plus 80. Right? But anyway, the reason you know this is a finite because you see a number at the end. So it doesn't keep on going, right? So that's how it's finite. You know it's arithmetic because it's 1 by 1. And so now you can plug it in to this formula here, or you can use this here, and you should, in each instance, get the same answer. Did you?
I got it.
Or-
It was 3,240.
3,240. Okay, doesn't that beat just adding up one of these at a time every time, right? Isn't that a better way to do it? That's like young Friedrich Gauss that we talked about yesterday in class.
Instead of a different answer, so I did say mine, but that's what I got.
You got a different answer?
No, I got 3, 2, 4, 0.
3240, okay. Yeah. Okay, this one here, find the sum of this one. I want you to try this one too. This one here is not okay. So for this one here, what I would get is I would start with k equals 0, and I get 2 plus 2k, and I go up to the 34th term. Does that make sense?
How'd you know it was 34?
Pardon me?
How'd you know it was 34?
The reason I did is I took the difference of 70 and 2, which is 68. So I know I have 68 in between 2, and I have to go up 68. And so I know the common difference is 2, so I divided 68 by 2 and got 34. So I know if this is the 0th term here, then this one, 70 has to be the 34th.
Okay, I see.
So I had to kind of work backwards on that a little bit. And once you do that, you just have, it just is an easy problem. What do you get for this one?
1,260.
1,260? Yeah. Okay? All right. Let's go on here. I want to get on the next exercise. Yeah. This one here, I'm just going to write out the answers really fast here on 11. What we have is our difference between these two is going to be 17, it's going to be the opposite, but 177 minus 33. And I'm just going to put this down here to make my subtracting easier. So that's going to be 4, and that's going to be 8. So there's 84 apart, and I realize that this 84 difference, or actually negative 84, and we divide by negative 7, what is this going to be? 9? It'll be 9. 12, 12, 12. So 12, so we're going to get 7, 8, whatever it is. It's going to, you know it's going to be negative 12, right? So here, we're going to have, our answer is going to be from k equals 0, we would go up, I'm not sure how many yet, we're going to start out with 117 minus 7k. And how many terms do we have here? Well, there are 12 total, right? So, I mean, we got 12 things. So we're going to go up to 12 like that. Does that make sense? So 0 to 12, and we plug that in, we'll get our answer. All right. And I'm not sure what that is. I watched the video on this last night. I did it well in the video, except in the video what I did is on some of the problems, what I did is a couple of problems, I wrote this little thing backwards. Anybody do that?
973.
973?
I mean, 75.
975? Yeah, sounds familiar. Okay, so that's that one. Next, a similar type of problem. I just want to go ahead and skip 12 to give time to go through these other ones. Now in 13 through 16 it says find the sum of the geometric sequence. So get a little experience working on geometric sequences. Well, I'm going to start this one out the same way we did these others. I'm going to start with k is equal to 0, and I'm going to have this, our starting amount, room 15, welcome. I have not seen her yet. But okay, now I don't know how much we're going up, but what's our initial value here? 3. What is R going to be here? 2. So we have 2 to the power of k. And what goes up here? Okay, let's take 12,288 and we're going to divide by we're going to divide by this thing right here, so 3. So how much did we go up to get that?
Why are you dividing with me?
Is this 4,000?
So you should just subtract it.
So 4,000, what'd you get 4,000?
2096.
4096?
Yes.
Okay, Nicole asked the question, why did I not subtract? The reason I did not subtract, for 2 reasons. One, I see that these are not the same apart. And I also am told that it's a geometric sequence. And so these two, the first and the last term, are that far apart. So what we have is 2 to the power of x is equal to 4096. Okay, 2 raised to what power equals 4096? Yeah, so what you would do is you could work it out. You can say log base 2 of 4096 is equal to x. And that will tell you what we have here.
It's 64.
64? Okay. So equals 64. So x is 64. So that would say 2 to the power of 64 equals, that doesn't seem right. It's going to be way higher than 4096.
That's what I have for you when I divided it.
Do you mean the digital?
No.
Okay, let's look at this. Log base 2 of 4096. Okay, here we go to math. Log base 2 base 2 of 4096.
It's
12. So x is 12. So we're going to go from k equals 0 up to 12. And then we should have our right answer in this case. So we had to sort of work backwards to find out what that is. And what did you get for your answer in this case?
44,573.
570, like this? Okay. Yeah, I find this is more challenging than the arithmetic one for obvious reasons.
In my opinion.
Okay. Okay, this one here is a similar type of thing. See if you can figure this one out, and we'll write out the answer in just a minute. Let me see what the 14. Let's see what the others are. Okay, yeah, we got to get to these.
147620.
Okay. I get, okay, oh, for the total answer? Yeah, so 6. Okay. Eight, 41, 3. So this is what I get here for the
Yeah.
so what we have is x, or 5 to the power of, so 5 to the power of, how did I write this one? It's 3 to the power of, that's right. Because these are 3 apart, right? 3 to the power of x is equal to 19,683. So that's going to be log base 3 of 19,683
9.
is equal to 9, because Nicole told me it was. So that means I can go from k equals 0 to 9, right? And we can put 5 times 3 to the power of k and get our correct answer. And you got that, Nicole? It was
147,620.
okay, 147, does that sound right? Okay. Now, the next one here is going to be a little bit simpler in that it's kind of giving you the telegraphs. So if we look at 15, we have 40, oops. I accidentally hit my tie.
That scared me.
So is my ears.
Yeah, that was my, it was the thing. All right, so here we have a common ratio, and what this is, you're dividing by 6. So R is equal to 1/6. And so what we have is, we're going to have, our answer is going to be like this. If we start at k equals 0, and what's our first term going to be? 42 times 1/6 to the power of k, and what's going to go up here? What's going to be 8, right? Because it gives you 8 right here. And so we're going to have our sum if we do that. I'm going to show you another formula for this too. Again, this is called what kind of a sum? Starts with a P, a partial sum, and we will call this, we call this the 8th partial sum. It's probably the 9th actually, because this would be 42 times 1/6 to the 0. So we have 42 times 1/6 to the 0 power. And so this is going to represent our 9th partial sum. And what do we get for that? 50.4.
Oh, yeah.
Yeah, you should get 50.4 for that. And there's another formula for it, and I'll show you on the formula chart where it is. It's this one right here. You see that? Sum of a finite geometric series. So a sub 1 minus r.
You gotta go to that other column.
Already did.
Okay. So for this one, we can write this as a sub 1 times 1 minus a to the n over 1 minus r. So in this case, what we have here is our first term, which is 42. Then we have 1 minus 1/6 to the power of, and they give us 8 over 1 minus r, so it's 1 minus 1/6. And we put this in here, we should get this same answer here. At least it worked out last night when I did it in the video. Well, I hope it works out. So we have 42 times 1 minus 1/6 to the power of 8. I hope that work out right. And then we have down here 1 minus r. I'll use the parentheses, just have the same. 1 over 6. And we should have,
Yep.
yeah, that's going to be it, okay? So that's this formula. So we'll say 50.4. That's using this formula here for partial sums. I think to me, I think that's a hard formula to do. I think it's easier to write it here with this summation like this, yes. Okay, that's the way I think of it. Okay, let's get to there we go. Okay, let's see where we are here. What happens is we are just about to the end of class just because of time. So go ahead and start working on number 16. I'm going to hand out the packet and other papers right now while you work on number 16, okay? We'll do that. And that'll be